Hello and welcome to the chemistry section of this video series. And in this video, I'll be taking you through the 11 most repeated topics in chemistry UTME. Now, every topic listed in the chemistry UTME syllabus are all important. But when you have factors like time constraints, then you can focus on these 11 topics, which are also part of the chemistry UTME syllabus. Now, we have the first topic, separation of mixtures. Under this, you're expected to note pure and impure substances. Pure substances have the same composition or constant composition, and we have examples, elements and compounds. And impure substances, they are the opposite. They do not have constant composition, and examples, we have mixtures. You're also expected to note chemical and physical changes. Chemical changes are not easily reversible, whereas physical changes are easily reversible. So note the various examples under these changes. You're also expected to note the separation processes. Of course, separation processes are applied to mixtures and it exploits physical properties of the various components of the mixtures. And some examples, we have filtration, we have evaporation, centrifugation, and the rest of them. So that's for the first topic. Now, the second topic, we have chemical combination. Under this, you're expected to note the laws of chemical combination. We have 4 laws, but you have to focus on the law of conservation of mass, the law of definite proportion, and the law of multiple proportion. And also, you're to note Gay-Lussac's law of combining volumes and Avogadro's law, while noting the molar volume 22.4 dm cube or 22.4 liters or 22,400 cm cube, and the Avogadro's number 6.023 times 10 raised to power 23. So you have to note how to use these figures. You're also expected to know how to balance equations and also how to write chemical symbols and formulas. That is for the second topic. Now we'll go over to the third topic, kinetic theory of matter. Under this, you're expected to note the kinetic theory of gases, very, very important, and also gas laws. We have the Boyle's law. We also have the Charles law. Of course, know that Boyle's law states that pressure is inversely proportional to volume when temperature is constant. Charles law states that temperature is directly proportional to volume when pressure is constant. And we have the ideal gas law, PV equal to N Aru T, where our N is the number of moles and Aru is the gas constant. You're also expected to look at Graham's law of diffusion and Dalton's law of partial pressure. Now, Graham's law of diffusion states that the rate of diffusion of a gas, X, is inversely proportional to the square root of its molecular mass. So if you're having two gases, X and Y, so you see that the rate of their diffusion is inversely proportional to the square root of their molecular mass. Now, Dalton's law of partial pressure states that the total pressure for a mixture of gases is equal to the sum of the partial pressure of the individual gases that make up the mixture. Now, this is for kinetic theory of matter. Now, we'll go over to the next topic, atomic structure and bonding. Under this, you're expected to note the concept of an atom. Note the constituents of an atom. We have the electrons, they are negatively charged. The neutrons, they are neutral, and then the protons, they are positively charged. So look out for their various properties. You also have the periodic table. You have to note the groups and periods of the periodic table, and also the trends on the periodic table. We have electronegativity, electropositivity, atomic radius, and the rest of them. How do they change across the periodic table? Do they increase or decrease down the group, or increase or decrease across the period? Now, types of atomic bond. We have electrovalent bonds, covalent bonds, and the rest of them. So you have to note the compounds formed under these bonds, the various examples of the compounds. You also have nuclear chemistry. So you have to look at the alpha particles, the beta particles, and the gamma particles, as well as their properties, and also radioactive isotopes. That is for the fourth topic. Now we'll go over to the fifth topic, acids, bases, and salts. Under this, you're expected to note acids and bases. there are various types. We have the strong and the weak acids, as well as the strong and the weak bases. So note the properties of these acids and bases as well as their uses. For salts too, you have to note the various types of salts, also their preparation, as well as their uses. Very, very important. You're also expected to look at the pH scale. Of course, you know that 7 is neutral, and any solution below 7 is considered acidic, and above 7 is considered basic. And also the expression for pH, you have pH plus the POH giving you 14, and you also have your hydrogen ion concentration times your hydroxyl ion concentration giving you 10 raised to power minus 14. You're also expected to look at acid-base titration. Of course, it is a neutralization reaction between an acid and a base to give you salt and water. So there's an expression for this. You have CaVaMb equal to CbVbNa. Ca is the concentration of the acid in mole per dm cube, Va volume of acid, and Mb number of moles of bases. And you note that you need to have a correct reaction equation in order to solve this, so you can get your number of moles of acid and bases. Cb is the concentration of the base in mole per dm cube, the Vb is the volume of the base, and the Na, the number of moles of acids. Now that is for the fifth topic. Now we'll go over to the next topic, oxidation and reduction. This is an interesting topic, and you're expected to note the oxidizing and the reducing agents. The oxidizing agent is reduced, and also its oxidation number is decreased. It gains electron, and there is a change from a higher number to a lower number in the oxidation number. And for the reducing agent, it is the opposite. It is oxidized, loses electron, and it goes from lower number to higher number. Now you're also expected to note the test for oxidizing and reducing agents, the various reagents, and also the color change. That is for the sixth topic. We have the next topic, electrolysis, a very interesting topic. Under this, you're expected to look at electrolytes and electrodes. Of course, we have the strong and the weak electrolytes, and for the electrodes, we have the anode, which is positive, and the cathode, which is the negative electrode. You're also expected to look at factors affecting preferential discharge of ions. Now, these factors, we have the position of the ions in the electrochemical series. We also have concentration and also the nature of the electrode. Very, very important. Now, also you're expected to look at Faraday's laws. We have the first and the second laws. Now, for you to be able to solve questions under Faraday's laws of electrolysis very important, very correctly, it is very important that you note the univalent monoatomic ions, for instance, the silver ion. Also note the divalent monoatomic ions, for instance, the copper ion, and then the trivalent monoatomic ions, for instance, the aluminium ions. So you have to note this, very important. And lastly, you should be looking at the uses of electrolysis. We have in electroplating, purification of metals, and so on. So that is for the seventh topic. Now we'll go over to the next topic, chemical reactions and chemical equilibrium. This is another interesting topic. Under this, you're expected to look at factors affecting reaction rates. Under this, we have temperature, concentration, catalyst, surface area, and light. So note how they affect reaction rates. And also Le Chatelier's principle. Le Chatelier's principle states that for a system in equilibrium, when the equilibrium is disturbed, this system tries to adjust itself in order to neutralize this disturbance or constraints. Now you note factors that affect a system in equilibrium like temperature, concentration, catalyst, and then pressure. How do they affect this system in equilibrium? What are their effects on equilibrium constant and also equilibrium position? That is for the 8th topic. Now we'll go over to the next topic, non-metals and their compounds. You focus on some non-metals like hydrogen, oxygen, chlorine, carbon, nitrogen, and sulfur. Under this, you're expected to look at their preparation, both laboratory and industrial level, their properties, as well as their uses. When I mean properties, I mean physical and chemical properties. We also look at their various compounds, as well as the uses of these compounds, and allotropes of nonmetals like sulfur and carbon. Note this, very important. So we'll go over to the next topic. We have metals and their compounds. Another important topic. Under this, you're expected to note the various groups of metals. We have the group 1 metals or the alkali metals. We have the group 2 metals or the alkaline earth metals. We also have the group 3 metals. You focus on the aluminium. And for group 4, you focus on tin and lead. And then you look at the transition metals, which have partially filled d orbitals. Very important, these are the groups of metals. Now you have to note the various ores of these metals and how they are extracted. You also have to look at their properties, as well as the various compounds of these metals, and also the uses of these compounds of these metals. Very important, you have to look at these, and you also have to look at the flame test for these metallic ions, as well as alloys that are formed from a mixture of 2 or more metals to have an improved metallic property. So that is for this topic. Now we'll go over to the last topic, organic chemistry. Organic chemistry is very vast and also very important. Under this, you're expected to look at isomerism. Of course, isomers have the same molecular formulas but different structures. So the different types of isomerism, we have to look at that. Types of hydrocarbons, I mean the aliphatic and the aromatic hydrocarbons. Look out for their various examples. We also look at the petroleum and crude oil fractions. We also have alkanes, alkynes, and benzenes. Now you look at their preparatory procedures, as well as their reactions, and then their uses. For the alkanes, you focus on the methane. Alkanes, you have the ethene, and for the alkynes, you have the ethyne. Now you also look at the properties of these members of these organic compounds. Now also, you're expected to look at the alkanols, the alkanoic acids, and the alkanoates, their various reactions, and also their uses. And you have to note the esterification reaction between the alkanols and the alkanoic acids to give you alkanoates. Note that, very important. And it is also important that you note the homologous series under these organic compounds. We are simply talking about the various families of organic compounds. You also have to look at the amines, the alkanals, the alkanones, carbohydrates, and fats. You have to look at their various reactions. They test to differentiate between alkanals and alkanones. Look at the fermentation of carbohydrates, as well as the types of carbohydrates, the monosaccharides, disaccharides, polysaccharides. Look at fats and also the saponification reaction between fats and alkalis to give soap. And also in your alkanes, and alkynes, you have to note the test to differentiate between the saturated hydrocarbons, which are the alkanes, and the unsaturated hydrocarbons, alkanes, alkynes. And also the test to differentiate between alkenes and also alkynes. Now, that is it for this last topic, organic chemistry. It is very vast. Make sure that you cover it to be on track. Now, in the next video, I'll be taking you through questions gotten from these 11 most repeated topics in chemistry UTME. Make sure that you don't miss it. See you in the next video.